Welcome everybody. Thanks for joining us. We got Synergy was kind enough to provide a speaker and a platform for all of us to kind of hang out together. So thank you very much, Jacek, and everyone involved. There's not a lot to say. Like I was just chatting before, but it's been a while since the last meetup. So thanks for hanging in and kind of attending on short notice, because it was usually we give like a month to like we announced it a month prior, but this was pretty quick, and I'm glad it's just before Christmas break. So thanks a lot. And yeah, and we don't have any announcement or anything, right, Gil?
Oh, thank you. Good evening. Thank you for inviting me to speak at the last London Python meetup, virtual one this year before Christmas. Welcome, everyone. My name is Jacek. I'm an eSynergy associate. I work with eSynergy, who are a cloud consultancy. They specialize in developing cloud solutions for clients, helping them develop cloud-native software and data analytics solutions. Personally, I've been in the software development industry for the last 20 odd years. Most of that time I spent building solutions using Python for various clients. I was lucky to have been involved with small startups, helping them get off the ground, or maybe scale to a bigger number of users, or cope with the rapid growth. I worked for media organizations and larger organizations within the financial services industry. Recently, I've been involved over the last 5 or so years with the open banking implementation entity, helping them build the open banking directory, which sits at the core of the UK open banking system. It is the source of trust and identity for the UK open banking system. It used to be more international, but then Brexit happened and we had to adapt to that as well. So that was fun, 5 years or so. Then I worked recently with a global recruitment agency, helping them with their digital transformation, moving from the old platform to something more modern, based on microservices, CRQS system, and currently working with eSynergy for a global e-commerce operation on the global shipping side of things, helping them scale and turn the system on that side of the business to be more performant and cope with growth. Because as we know now during pandemic times, we are sort of locked up, fully or partially oftentimes. So we order more stuff online, and that creates interesting problems for everyone in retail space and in the shipping industry. But today, I'm going to tie that into a talk which came about when I had a conversation with my friends about blockchain. As we know, there's a lot of hot money flowing into the blockchain space, and it's a bit like the early days of the internet, only more intense, I would say. And we were wondering with friends how Python and how we as Python developers can stay relevant in that space. So this talk is about how Python is relevant to blockchain and how to stay relevant when everyone seems to be wanting blockchain developers build blockchain solutions, whether they actually need them or not. So that's what I want to talk about tonight, because I firmly believe that blockchain is in our future, whether we care for it or whether we care for crypto or not. And this talk is not about crypto. I do not want to talk about it tonight. But blockchain, I think, is going to be, I not only think, I firmly believe that blockchain is the technology that will become one of the basic requirements for any new roles or a lot of new roles coming onto the market and for projects being realized, being delivered starting next year, starting next year, 2022. This process has already started, but there's a lot of demand for developers who know how to program for the blockchain. And that is not going to be enough. I think that we as Python developers are uniquely positioned to benefit from that change because Python over the last 2 decades has not only survived, but also grown together with the IT industry. Python is uniquely positioned as a programming language to be what it sort of started selling itself with as the glue that ties different systems together. And this has only become more important as the years went by. We saw a lot of new frameworks being developed for Python. We can build commerce websites, all sorts of websites using Python, using frameworks like Django. We can build APIs using frameworks like Flask, Fast API. And we can see that Python is being used in AI, is being used in data science. Like everyone, whichever industry we go into, Python is no longer the language that we have to sneakily use on a project without telling anyone until it's actually done and delivered, or until we get discovered, as it used to be with open source. Now Python is actually required. People say, whether they have a good idea and good reasons for using Python or not, quite often clients will say, well, how about Python? Can we build it using Python? So it has become one of those languages which are very well known and very well and quite widely accepted. And it's not necessarily competing with the likes of Golang. It's just growing as the space and demand for software grows. So this has happened because, like I said, there's a huge ecosystem of modules, and for one reason. And the second reason would be that it has survived the transition from Python 2 to Python 3, which we know that was a big concern to our community, because we, until recently, remembered the fate of Perl and Perl 6 and how it didn't happen quite well. Didn't turn out quite well for Perl. But Python has survived that change, that major change, and is growing. Not all of the changes that we are seeing are perhaps to our liking, but that's okay. The overall market for Python developers has been growing. It's at the top of the rankings for developers. The anecdotal evidence of the importance of Python is that when you go on YouTube, you sometimes search for a tutorial or some information, and you get ads for courses specifically mentioning Python. I get harassed by those ads quite often. I'm sure a lot of you see them as well. So what does it have to do with blockchain? Let's have a look at the blockchain ecosystem and which bits of that ecosystem we should be interested in. So there are two major characteristics of blockchains, because there's more than one, that make them interesting to investors and clients. One is that it is a cryptographically protected ledger. The integrity of the information on that ledger is ensured cryptographically, and it is used to store transactions. And those transactions are more general. People think of transactions as sending money, and that is absolutely one of the core uses of blockchains. But also the more advanced blockchains allow for deployment of applications. Once you deploy the application code onto blockchain, that code stays there and it is immutable. You cannot change it once it's deployed. On the flip side, you never pay for hosting that code. That code stays there forever, for as long as the blockchain exists. So, and that code is called programs written for the blockchain in the native language of the blockchain, or I should say in the native language of the virtual machine, which is associated with the blockchain, are called smart contracts. After the idea that code could be law, code is law, because once you create a hash of a piece of code, any changes make that to the source code, make that hash invalid, therefore the code is invalid. So you always go to the source, to the having a hash of the source code, and you can be sure that you are executing the same set of commands. And the most popular virtual machine that allows for that to happen is EVM, the Ethereum virtual machine. And it has been cloned by a lot of projects. So you get a lot of clones of the Ethereum blockchain and the EVM, like Binance Smart Chain, Polygon, others. And once you write your smart contract for the Ethereum blockchain, you can then redeploy it on different blockchains. That's why it's become so popular. And the language used to write those applications is called Solidity. Solidity is unlike Python. However, because it gets compiled to bytecode, you can use another language and compile it to bytecode. And there is a project called Viper that looks very similar and is based on Python. So once you can transfer your Python skills there. However, from my experience over the last 2 years, I would say that that Viper is less popular and it's always lagging behind Solidity. So if you want to start exploring blockchain space, you should be looking into learning Solidity. Fortunately, you can probably learn it over a weekend or maybe 3 days. Follow a good course, like good Udemy courses on programming in Solidity, and learn how all of the pieces of a decentralized or dApp application fit together. Because there are essentially 3 parts. There is the code that gets deployed onto the blockchain, written in Solidity, compiled into EVM bytecode. Then, for most of applications that the ordinary people use, there will need to be a front-end part, and that's usually written in React. Not much to do for us as Python developers. But then there's the third part, and this is interesting, where we see big backends being developed in various programming languages. And why not use Python for that? Python allows for rapid development. From my own personal experience from projects, we were able to deliver extremely time-sensitive projects with deadlines set by governments, and those deadlines were immutable. We couldn't move them. They were immovable, rather, I should say. And we delivered them in 4 months. Then the next iteration to implement the new features and then adapt to changes in the regulatory landscape required more time, but also not just because there were changes, but also because someone has pushed for this thing to be re-implemented in Java. And what we built in 4 months then took 2 years to re-implement in Java. So, those things point me, my experiences with using Python and other programming languages point me towards choosing Python as my first choice, essentially. So I think a lot of backends, like gaming backends, business backends that will be connected to decentralized apps, will be written in Python. And I personally, for my own benefit, because I'm invested in Python, I think they ought to be written in Python. So how do you connect? How do you begin writing applications for blockchain? Well, there is an interface library called Web3. After the Web 3.0, the moniker that is now sort of getting popular, like Web 2.0 in the past. Now, anything that runs on blockchain or is somehow connected to blockchain or maybe sits next to a blockchain is called Web 3.0. So if you learn that library, and it's not very complex, you will see what it allows you to do. Read transactions from blockchain, read blocks, post transactions to blockchain, post application code, or bytecode, I should say, and then maybe interact with applications that deploy to blockchain. And once you learn it, all of your experience so far will guide you towards possible applications of blockchain. You will start seeing how this new technology could benefit your current clients and future clients. Because once again, Python will be the glue language to to connect the two worlds, because we need to build bridges between different blockchains and blockchains and the internet. Currently blockchains in the pure format are sort of isolated. They run on top of the internet infrastructure, but Solidity out of the box does not allow you to make HTTP requests, for example. So you need to find ways, creative ways, to enable passing of data and requests between code deployed onto blockchain and the code that already exists, or the code that you may be wanting to build, or your clients may be wanting to build. So that's why I think you should learn how to code in Solidity, how blockchain works, how Web3 library works for Python. And then another thing that you have to learn has very little to do with blockchain as such, but a lot to do with your clients. You have to learn to help clients. And this is why I went outside of my comfort zone. After spending a few years on the open banking project, I had some opportunities to work in the financial industry. But I thought, well, if blockchain is going to be the future, then I need to learn more about the industries which are perceived as being the laggards, the old industries that are not at the cutting edge of technology. Not always true, but often true. And I started looking at different industries. That's why I started working for this on the project for a global recruitment agency. They had an issue with the systems. They absolutely had to move to a different system. And that has taught me a lot about the inner workings of the recruitment industry. And then I was approached by eSynergy to work with their client, like I said, a global e-commerce operation that also has a massive global shipping operation on their hands, which is exploding in growth. And that has opened my eyes to the question of, what we think of, for example, what we think that high performance means to us and to clients, what scalability means to us as developers and clients. So I will give you two examples. In the open banking ecosystems, banks and third parties who are allowed to take payments within the framework, the regulatory framework that is open banking in the UK, have to prepare themselves for receiving millions of API requests per month. Similarly, e-commerce operators on the front side, on the shopping side of things, when we are shopping, when it's a Black Friday, Cyber Monday, Christmas shopping, other times a site gets popular, it has to withstand those millions of requests. On the global shipping side of things are slightly different, because we are dealing with packaged goods. I like to joke that we are dealing both with Docker containers with this client and proper containers, the steel ones that get shipped across the ocean. So we sometimes have to clarify which ones we're talking about. And there we are surprised, because the definition of performance and scalability is different. Our clients sits, the global shipping operations sit in a very interesting place where your orders may not get fulfilled immediately from the warehouse. Therefore, they have to be sent to the factories, and the factories will send the items to overseas agents, as they are called. And those agents handle the loading of containers and putting them on ships and sending them across the ocean to the United States, to Europe. And it would be nice if those goods arrived on time, if they were the goods we ordered, and if they were loaded onto containers in such a way that we don't upset the balance of the container when it's being lifted up and down. And when the container gets onto a truck and the truck has to make a few stops along the way across the United States, then when someone opens the door, they can easily get to the items, the boxes. So there's a lot of challenges there. But there's another challenge of making different systems work. And we are used to developing APIs. And some of those parties involved in shipping let's say, the table you ordered from the factory in China to your home, along the way, there will be a chain of parties who are putting data into the systems, and those systems cannot talk to each other easily. And the bottleneck is not the performance of a server, because they are dealing maybe with a few thousand containers per year. They will be dealing with over a dozen of thousands of containers per year, maybe 20,000 containers per year. Even if you have 100 requests per a container, and the boxes that get put into the container and then unloaded, we're talking maybe a couple of million requests per year. So where's the problem? Any server can handle that, except you have humans in the chain. And those humans copy and paste data from one system to another, and they do it several times. And then they fill out paperwork. And at one point, some of them draw a box on a piece of paper, and they draw smaller boxes, and they say, those boxes go to California, the other boxes go to Texas, and the other boxes go to New York. So we are working on improving performance and scalability by removing humans from the equation, by developing APIs and building API translation layers between different suppliers, different operators. And those operators are also working with us. They may be translating from REST to GraphQL, from GraphQL to SOAP, to email. That happens too. And that gave us a different perspective on what the business wants. And this is very important. This is taking us back to blockchain. If you want to be a successful developer as a Python developer in the blockchain space, you have to learn how to answer your clients' questions on the subject of usability of Python, applicability of Python, of blockchain. How do we integrate blockchain, and why would we integrate blockchain with the systems they already have or the new systems they want to build? And one of the selling points of blockchain in the shipping industry, and this is where this industry is going, is the global supply chain audit. So there are a lot of regulations around the world to do with anti-slavery, counterfeit goods, fair pay, environmental impact, taxes, import duties, sanctioned countries, organizations. There are sanctioned persons, for example. The Department of State has a list of those, a very long one, goods and services. And blockchain as an immutable ledger is being seen as a very attractive means of storing that information in a way which cannot be tampered with, or is very computationally expensive to be tampered with, and therefore easily detected. So my answer to the question that my friends have asked me, how do we as Python developers stay relevant within the blockchain space, is learn the basics of blockchain and a few libraries that already exist in the blockchain on the Python side of things, but then work in different new industries and learn how they operate, and that's how you learn how to apply blockchain and the skills you already have, and help clients achieve their goals. That's my spiel. That's how I help answer those questions the friends and clients ask me. And like I said in the beginning, I believe that as Python developers, we can help our clients because we can tap into a rich and huge ecosystem of modules and solutions that already exist. There are few other programming languages that can compete with Python in that space. And also the low barrier to entry has allowed a lot of people from outside of computer science, educated population, to come join the party and write extensions for their own needs. for their own businesses, for their own academic needs. And that has created a fantastic opportunity for everyone writing Python to be a valuable developer in the blockchain space, other spaces as well, but in particular in blockchain, because sooner or later, the blockchain echo chamber will start looking for ways to connect to the outside world. And those solutions are being developed already. And we should be there ready to benefit from that. So that's my talk for tonight. Thank you for listening. And I would like to open the floor to questions if you have any.
Hey, thank you very much, Jacek. We only have one question from Adrian Rosiola. I think that's his name.
Yes.
He says, can we have some examples of real projects? What was the blockchain used exactly, and what problem did they solve?
Okay. So there is a question. I mentioned the global supply chain. And there are two projects already being on the market, offered to the global shipping market. One is based on the Oracle clone of the Ethereum blockchain, and Oracle is selling that solution to shipping companies to store transaction data. That's not payments, essentially, exactly. It's to store pointers like IDs of documents connected to a particular shipping. A shipping order, for example, is a very complex thing. To us, it means, well, ship me my table from China. To the retailer and the shipping agents, it means assign a specific number to the product, to the box, then group those boxes into a group of boxes that fit into a container, connect the dots, connect the IDs of the boxes with the ID of the container, connect the ID of the container with the shipping order, the document that is sort of tracking this journey, connect that ID to the ID of the ship, connect those IDs to the port IDs, and then once you connect those dots, remember to connect the IDs of those physical things with documents like taxes have been paid, duties have been proof that duties have been paid, that goods are or have originated from countries which aren't sanctioned, that the goods meet anti-slavery regulations, and they have been the full audit. So then whenever somebody's asking for that information, it's available and it can be made public. So, for example, if the members of the public are interested if perhaps certain goods imported into the country meet the standards of the country that the country has imposed on importers, that this can be verified because that data cannot be tampered with. And a similar offering is being built by a consortium of shipping companies based in Hong Kong. They do the same thing. Basically, a long audit trail which is stored on an immutable blockchain. Similarly, large banks on Wall Street have built their own Ethereum-based blockchain for handling large transactions. So they no longer use the ACH system for equivalent of faster payments or BACS in the UK to send money. In the United States, they use that to record transactions amongst themselves in a more efficient and faster way.
Thank you. We got another two questions. We got Thomas Rumble is asking, do we think that the current internet will continue to persist and interact with a parallel set of blockchain networks, or everything will end up on chain?
Absolutely. Both technologies will coexist. Blockchain cannot replace the internet. It is not designed to. It isn't fast enough. It isn't scalable enough, and it cannot do everything that the ordinary internet built on TCP/IP stack can do. So those technologies will coexist, and proof of that is the development of what is called oracles, which are cryptographically protected sources of information or cryptographically confirmed sources of information obtained off-chain. There's on-chain information and off-chain information. When we talk about off-chain information, it means from the sources which aren't on the blockchain. And yeah, absolutely, those two worlds will coexist together, and we will develop bigger things than the sum of them.
Thank you. One more question from Adam Topping. What do you see as the biggest blockers for the uptake of blockchain in the traditional industries we have discussed?
Education. Client education is always the problem. And I speak from experience not related to blockchain, but related to APIs. When I joined a certain project inside the financial services industry, there were a lot of people from the old financial industry, and APIs were a new thing to them. And I thought, this is not right. This is 2017. We should be not having those discussions. So you have to understand that the adoption of technology is not instant across the board. It is gradual. So it just takes time and education. We have to educate clients and show them proof of solutions.
Right. We got one more coming in. So we got an anonymous attendee is asking, what do you think of frameworks like Brownie?
I haven't used Brownie, so I can't comment.
Cool. And we got Simon Harrison, which I believe is one of our co-organizers. He's asking, is there more to this than just trusted and robust audit trail?
So yes, a trusted and robust audit trail is one thing, absolutely. And second, ability to run applications and store the results of those applications, the operation of those applications perform. Again, that sort of ties into the robust audit trail. Also, there are fascinating concepts like NFTs. So you build a NFT, the non-fungible token that you hear about in the news. It's essentially a piece of code. It's a smart contract attached. Currently, the most popular ones are attached to a piece of some graphic, like an ape or some other icon. But it can be more advanced. For example, you can write that contract in such a way that every transaction benefits the creator. So every time the NFT is sold, a commission is paid to the original creator. That creates interesting applications. You can control access with NFTs, for example, or with other tokens, with currencies. You can via a web app, a library like Web3. There are Web3 libraries for almost all languages, including JSON and Python. So you could interrogate somebody's wallet, the content of it, and you can say, if you hold X amount of a specific token, I will allow you to access my service. So it's not you may not have to pay, but you may have to own a token, just like you're a member of, let's say, Royal Yachting Association, right? And you cannot join the club, yachting club, or you cannot get a radio operator license without being a member. That will be used to control access, for example. There are also interesting concepts around governance. You can create what are called DAOs, decentralized autonomous organizations. Smart contracts that don't need an office, that don't need any infrastructure except blockchain, and that take decisions based on the votes they receive. And people who vote with a specific token of some kind, let's say with Ethereum currency, and then that organization has an account associated with it. Each smart contract has an account, like an address where the funds are held. And we can vote on whether or not, for example, we should assign some piece of work to somebody and how much we will pay them. And then people vote with money, and that money, if successful, if the vote is successful, that money gets released and assigned to a particular, another address which belongs to a person. and that person does work. Those experiments have been conducted in, I believe, in Wyoming. There's the first DAO that has become autonomous, fully autonomous. So there's no CEO, there's no accountant, it just exists in blockchain.
Oh, nice. So one more question from Ivan Valderrama. Is Python big in this space now, or is still room for growth?
There's plenty of room for growth, but Python is a first class citizen. It has a very good Web3 library, so you can start writing code that interacts with blockchain immediately. I would still advise that you learn how to code in Solidity, because a good course on Solidity will introduce you to the concepts of how the blockchain works and how to interact with the apps, not just the blockchain itself, but how to interact with dApps, those apps deployed onto the blockchain.
Right. Cool. So I think that's all the questions that we had in the Q&A. So
Thank you.
Yeah, thank you very much, Jacek. That was very, very insightful.
Thank you.
Yeah, and thank you everybody for coming. Thanks for joining in this last meetup of the year. And hopefully we'll pick up and get more going as 2022 starts. So thank you very much, everyone. Have a great evening.